Ever get frustrated trying to parallel park, especially when you know there's a perfect spot just waiting to be found?
Definitely, especially in the city.
Today's deep dive is all about finding those perfect solutions.
Okay.
But instead of parking spaces, we're talking about the fundamental laws of physics.
All right.
We're diving into the world of particle physics
Okay.
and a new method that uses the power of quantum computers to unlock the secrets hidden within massive amounts of data
Wow.
from particle colliders.
Okay, so look, and it's a really clever approach because it tackles one of the biggest challenges in particle physics,
Which is?
how to make sense of incredibly complex theoretical models.
Okay, so we're dealing with particle colliders,
Right.
massive data sets,
Yeah.
and quantum computers.
Uh-huh.
Where do we even begin?
So imagine this.
Okay.
Physicists smash particles together at nearly the speed of light
Wow.
in something like the Large Hadron Collider. These collisions are like microscopic explosions that give us glimpses into the fundamental building blocks of the universe.
Good.
But here's the catch.
Okay.
These collisions produce an overwhelming amount of data.
We're talking mountains of data, right?
Yes.
Like trying to understand the entire history of the universe by looking at a single grain of sand.
That's a great way to put it.
Really?
And to make sense of this data, physicists use something called effective field theories, or EFTs. Think of them like simplified maps.
Okay.
If you're trying to navigate a city, you don't need a map that shows every single crack in the sidewalk.
Right.
You just need the major landmarks and streets.
Right.
EFTs let physicists focus on the specific interactions that matter most
Okay.
for the problem they're trying to solve.
So zoom in on the important details without getting lost in the weeds.
Exactly.
It makes sense. But where do the quantum computers come in?
So within these EFTs,
Okay.
there are certain parameters, think of them like adjustable knobs,
Okay.
that physicists can fine-tune to try to match their theoretical models to the data.
Okay.
Finding the absolute best values for these knobs is crucial,
Right.
but it's like searching for a tiny needle in an enormous haystack.
Okay.
And this is where quantum computers come to the rescue.
Because they can process information so much faster than regular computers.
That's part of it,
Okay.
but it's more about how they process information.
Okay.
They use a process called quantum annealing,
Okay.
which you can think of like a superpowered search algorithm.
Okay.
Imagine trying to find the lowest point in a vast mountainous landscape.
Okay.
Traditional methods might get stuck in a valley that seems like the lowest point,
Right.
but it's not.
Oh.
Quantum annealing is like having a bird's eye view of the entire landscape,
Okay.
allowing it to zero in on the absolute lowest point, even if it's hidden among other valleys.
So it's like having X-ray vision for data analysis.
Yeah.
You can see through all the noise and find the hidden gem.
Right.
That perfect fit for the theory.
Yeah.
Hence, quantum fitting.
Exactly. This new method, called QFitter,
Okay.
takes advantage of quantum annealing to find the best possible values for those knobs in the EFTs,
Okay.
matching the theoretical models to the experimental data with incredible precision.
This QFitter sounds like a game changer.
It is.
But how do we know it actually works?
Oh, yeah.
Did they put it to the test? So they put it to the test.
They absolutely put it to the test.
Okay.
The researchers who developed QFitter wanted to see how it would perform in different scenarios.
Right.
So they designed 3 tests,
Heck no.
each more challenging than the last.
Okay. So it's like they set up an obstacle course for QFitter
Yeah,
to see what it could handle.
exactly.
Yeah.
The first test was like a warm-up
Okay.
using a well-established physics problem
Right.
to make sure QFitter could replicate known results.
So like a control.
Think of it like
Okay.
making sure your new oven can bake a perfect chocolate chip cookie
Right.
before moving on to a complex souffle.
Okay. Got it. It's there.
Yeah. So QFitter nailed the chocolate chip cookie test.
Yeah, it did.
What about the souffle?
Okay. So the second test
Okay.
involved a more intricate scenario
Okay.
with 8 of those adjustable parameters we talked about earlier.
Right.
And to make things even more challenging,
Okay.
they included something called quadratic terms,
Okay.
which are like hidden valleys
Yeah.
within the data landscape.
Okay.
Easy to get trapped in if you're not careful.
Right.
Yeah.
But QFitter navigated those hidden valleys without a problem.
That's right.
Wow.
Even with the increased complexity,
Okay.
QFitter found the optimal values,
So
demonstrating its ability to handle more realistic and challenging problems.
2 for 2.
That's right.
I'm starting to see why this is such a big deal.
Yeah,
But there was a third test, right?
there was.
The one with the truly treacherous terrain.
You're catching on.
Okay.
They called this one the non-convex Higgs fit.
Okay.
Imagine a vast, rugged mountain range.
Right. And somewhere within that range is a deep, hidden valley. the
Okay.
global minimum.
Right.
But here's the twist.
Okay.
Nearby is another valley
Okay.
that looks incredibly similar,
Uh-oh.
but it's slightly higher.
A decoy valley.
Yes.
So it's like those optical illusions where your brain wants to see one thing,
Right.
but it's actually something
A
else.
perfect analogy.
Wow.
And that's precisely what happened with the traditional methods.
Oh,
They
no.
consistently got tricked
Really?
by the decoy valley,
Whoa.
settling for a good enough solution. But QFitter saw right through it.
No falling for decoys this time.
Nope.
Uh-huh.
Peter consistently honed in on the true global minimum,
Okay.
proving it has the precision and power to avoid those deceptive valleys
Okay.
and find the absolute best solution,
Yeah.
even in the most challenging scenarios.
This is incredible. It's like QFitters playing chess.
Yes.
While traditional methods are stuck playing checkers.
Right.
They don't even see the whole board. What are the implications of this? I
Yeah.
mean, we're talking about getting a clearer picture
Yes.
of the fundamental laws of physics, right?
Exactly.
Wow.
Think about it. How many times have we missed crucial insights
Right.
because our tools weren't sophisticated enough to see past
Right.
those decoy valleys in the data?
That's a mind-blowing thought.
Right.
It makes you wonder what we might have missed all these years.
Yeah.
So what's next for QFitter? Is it ready to unlock all the secrets of the universe? So what's next for QFitter? Is it ready to unlock all the secrets of the universe?
It's definitely a huge leap forward.
Okay.
Even QFitter has its limits,
Okay.
at least for now.
Okay.
Think of the most powerful sports car in the world.
Okay.
It can only go as fast as the laws of physics and the technology under the hood allow.
Right.
Quantum computers are incredibly powerful,
Yeah.
but they're still in their early stages of development.
So it's like trying to run the latest, most demanding video game
Right.
on a computer from the early 2000s.
Exactly.
The potential is there,
Yeah.
but the hardware can't quite keep up.
But the algorithms and the theory behind QFitter are incredibly promising.
Okay.
But to tackle even bigger questions,
Right.
to really push the boundaries of our understanding of particle physics,
Okay.
we need more powerful quantum computers.
But those are on the horizon, right? It feels like we're
Yeah,
on the verge of a golden age of discovery in particle physics.
definitely.
What are some of the mysteries that QFitter might help us solve once those more powerful quantum computers arrive?
Let's talk about dark matter.
Okay.
We know it exists.
Right.
We can observe its effects on galaxies and the universe as a whole,
Right.
but we have no idea what it's made of.
Right.
QFitter could potentially sift through the data from particle collisions
Okay.
and uncover subtle clues,
Yeah.
those faint whispers
Right.
that point us toward the true nature of dark matter.
That would be incredible. Unmasking the invisible, finally understanding one of the universe's biggest secrets.
Right.
Are there other big questions that QFitter could help answer?
Imagine being able to peer back in time
Okay.
to the very first moments after the Big Bang.
Wow.
There's a whole era of the universe's history that remains shrouded in mystery, hidden from our view,
Right.
Fitter, with its ability to analyze incredibly complex interactions,
Yeah.
might be the key to unlocking the secrets of that early universe.
Wow. That's a lot to wrap my head around.
Yeah.
It sounds like QFitter isn't just a tool for analyzing data.
Right.
It's a potential window into the universe's greatest mysteries.
Absolutely.
And the most exciting aspect of all of this is that we're just scratching the surface
That's right.
as quantum computers evolve.
Yeah.
So too will QFitter and the possibilities for discovery.
It's an exciting time.
It's like we've been given a glimpse of a vast, uncharted territory, and we're just starting to explore its edges. This has been an incredible deep dive, full of mind-bending concepts and tantalizing possibilities.
It has.
I don't know about you, but I'm left with a sense of wonder and excitement about the future of particle physics.
Me too. Me too.
What do you think awaits us out there in the quantum realm?
The possibilities are endless.